Okay, 4.1.19b. The best way to solve this is through Fermat's little theorem, but this version right here. If you use this version, it'll take many iterations to solve. So what you want desperately is to have an x to the 12th here, because that'll be 1. So all this cancels out to 1. And that's just an initial way to reduce the equation down to something more manageable. So then we end up with an x to the 9th here, which comes down here. And then the same thing over here. So we want an x to the 12th, so we can end up, this all ends up being 1, so we get an x to the 8th. So now we're left with this equation, and this is what we're going to be working with. So what I found, just doing the standard methods that we've already learned about, is that there's no solutions. And for example, this is probably the hardest part right here to reduce this down, so let's just go ahead and do that as an example how to reduce it. So 12 to the 9. Well, in let's just look at 12 squared in Z13. So I'm getting, hold on a second, just using my calculator here. I'm getting that that's actually 1. So 12 to the 9th is equivalent to 1 in Z13. So what I'm going to do is I'm just going to take this and just say that's 12 squared to the 4th power, right? That's 12 to the 8th times 12. So I know that that's equivalent to, 12 squared to the 4th power times 12. Okay, so I know that's 1 to the 4th times 12, which is equivalent to 12 mod 13. So again, you can just use these Fermat's little theorems, and you could reduce it down however you really feel like it. But that's definitely go with this route first, where you reduce the whole equation down.